So we've got our aiming line in, but obviously it would be a whole lot more useful if, say, it tracked our mouse and actually showed us where we were aiming. So let's do that now. Now this part of the process should be pretty easy because we've done most of the heavy lifting in this show line function. All we really have to do now is make sure that we are calling this in the right place. So let's go back to our main Puggle class, and I guess first things first, this is probably not the right place to be calling it. So let's get rid of that. Instead, if you think about it, we really want to draw this aim line every time the player's mouse moves so that we can show the player exactly where their ball is going to be traveling. So I suppose I actually could call this show line function pretty much every frame, and that would work, but maybe to save myself a few cycles, I will call it whenever the player moves their mouse, and I can do that using a mouse move listener. So I'm going to add a mouse move listener to my stage, and we'll have it call show aim line. We'll generate this handler, and I'm just going to cut and paste this maybe a little closer to, say, here. And the first thing we're going to do is I'm going to check and make sure that we don't already have a ball in play. So I'm going to check and make sure that current ball is null, because obviously if current ball is not null, that means we have a ball in motion and we probably don't care about updating the aim line. So once we've checked for that, remember that our show line function requires 3 arguments. The first is the point you are launching from, the second is the general direction you're launching to, and the third is going to be the overall length of this velocity vector. Now, the first and third arguments we pretty much already have. They're constants at the top of this file. For the second one, let's call it direction. We're just going to need to find out basically the line from where we're launching from to where our cursor is. And to see what the math is going to look like, let's just take a look at this quick little diagram here. So let's suppose we got our launch point at 350, 20, somewhere close to the center and the top of our screen. If our cursor's over here to the left at 50, 80, to figure out the direction from our launch point to our cursor, we take our cursor's location, subtract the launch point's location, and we get something like, say, minus 300, 60, or basically to the left and down, which is pretty much the line that we would want to go from our launch point to our cursor. So if that kind of makes sense, let's go back to our code, and we're going to figure out our direction by taking our mouse location and subtracting from that the launch point. So this is going to be a new point. We're going to take the mouse X and the mouse Y, and we're going to subtract from that our launch point, which is where we're launching the ball from. And actually, that's pretty much all we need. Now I'm just going to call aiming line. I'm going to call the show line function. So our start point is this launch point constant that we've defined at the top of our file. The direction is the direction that we just figured out above. And our velocity in pixels is this launch velocity constant. Save all this, run it, and all right, looks like we have an aiming line, and it looks like it is roughly tracking our mouse cursor. Let's see how accurate it is. If I shoot about here, I should just nick the left side of that peg on top. It looks like it does. It's pretty close. Let's try a couple more shots. Maybe I can scoot in between these two just barely. Yeah, that seemed to work pretty well. All right, I think I'm pretty happy with the way this is working. One note, by the way, is if you find that your aim line isn't accurate enough, you can jump back to your aiming line and change this granularity from 20 to something like 30 or 40. That will give you an aiming line that is much more accurate, although keep in mind you're now making it do much more work every time you call this function, so maybe only do it if you find that it's necessary. 20 seems to be working pretty well for me. I could go up to 30, but we'll just leave it like this for now. The one other thing we should probably fix is let's have the aiming line go away once you launch a ball into the air. So I'm going to add in my aiming line class just a hide function that will take the graphics and clear it. And over in my Puggle application, if I look for launch ball, after I launch a ball into the air, I can hide my aiming line. And actually, there is one more tiny little bug I want to fix. I've noticed that if I don't move my mouse at all and I launch the ball off screen, the aim line doesn't come back until I actually start moving the mouse again, because we're only drawing the line on a mouse move. So maybe just to fix that, in my handle ball off screen listener, I could also say, call my show aim line listener, and I'll just pass null. So now if we run all of this, so this isn't going to look a whole lot different than before. The main difference now is once I launch my ball into the air, the aiming line disappears. Granted, it was kind of nice to have before for debugging purposes, but I suppose for the actual game it's nice to have it go away and come back. The other thing I'm going to try here is I'm going to take my hand off of the mouse and confirm that when the ball moves off screen, yes, I get my aiming line back, even if I'm not moving the mouse. So there you go. I think that's kind of it. If you look at it now, we've pretty much got all of the major features in and working that we set out to do at the very beginning of the lesson. I mean, we've got real graphics now. Granted, they're my crappy graphics, but you could probably find better ones that are now representing the box 2D physics objects. We are able to detect when two objects collide and make something happen to one of those objects that's colliding. We've got this cool bonus shoot where the ball is able to collide off of the sides but not collide in the center. And we're able to make this aiming shoot move left and right instead of just falling into our world. We've got our cool camera zooming in and slow down effect. And we finally got an aiming line working. So it does seem like we've got most of the major features in and working. And that's pretty cool. I guess what we've got left are sort of some of the smaller final touches. I'd like to make a few adjustments here and there to get the look and feel a little better. I think probably there's some nicer tweaks we can make to the graphics, so we'll look at some of that stuff. And then when we're done with that, we can look at changing this game a little bit so that maybe it's not quite the straight Peggle ripoff that it is now. I think that would be nice. I would appreciate it. The guys at PopCat would appreciate it. And so we will tackle all of that over the next few lessons. So all the major features are in, but we're not done yet. Stay tuned.